You walk into your house and the lights turn on. Your thermostat adjusts before you notice the temperature. The garage door closes behind you without touching a button. Somewhere in your walls, ceilings, and furniture, sensors are watching, but you'll never see them. And if you're not careful, they'll phone home with more data than you ever agreed to share. I'm Chelsea Miller, and I've spent 3 years testing these hidden devices to find out which ones can work completely offline and which ones are surveillance tools disguised as convenience. You're listening to the Smart Home Setup podcast. Quick heads up before we get rolling. All the research, testing, and writing you're about to hear comes from real human authors who've actually used this gear, but the voice delivering it is AI generated. Just want to be transparent about that up front. If you've been listening for a while, thanks for being here. It genuinely means a lot. And if you're new to the show, great to have you along. We drop new episodes every Monday, Wednesday, and Friday, tackling smart home tech, automation protocols, privacy concerns, and figuring out what actually works without selling your data to the cloud. Today, we're going deep on covert smart home sensors, the invisible tech powering your automations and, if you're not careful, building a profile of your life you never agreed to. Let's get into it. So what exactly are covert smart home sensors? They're monitoring devices deliberately designed to be concealed within your living environment while collecting data on motion, temperature, humidity, contact events, or presence. Unlike standard sensors with visible indicator LEDs and branded plastic housings, covert sensors are built to disappear, installed behind furniture, embedded in walls, disguised as everyday objects, or miniaturized to the point of invisibility. Now, the term covert doesn't automatically mean nefarious. You might want hidden sensors to maintain your home's aesthetic, avoid tampering by children or guests, or implement security monitoring without advertising your system's layout. I use covert door sensors in my rental property because visible sensors get torn off by curious toddlers every other week. But here's what manufacturers won't tell you. Most covert sensors are specifically engineered to be cloud-dependent. That miniaturization comes at a cost. Reduced onboard processing power means more reliance on remote servers. That disguised contact sensor shaped like a picture frame hook, it's probably sending your door open timestamps to AWS every 30 seconds, building a behavioral profile you never consented to. When I audited 23 discrete sensors in 2024, 19 of them transmitted data to manufacturers' servers, even when local-only mode was allegedly enabled. The smallest form factors were the worst offenders. Less room for local processing means more cloud dependency by design. The functional difference between covert and visible sensors is purely physical. They use identical protocols. Zigbee, Z-Wave, Thread, Matter, Wi-Fi, identical automation logic, and identical failure modes. The only thing that changes is whether your guests can spot them. If you're building a hidden smart home setup, understanding protocol implications matters more than the housing design. Now, let's talk about how these covert sensors actually work. The mechanics are identical to visible sensors. They detect physical changes in their environment and transmit that data using wireless protocols to a hub or directly to other devices. What differs is the packaging, mounting method, and often the power delivery system. Starting with detection mechanisms. Motion sensors use passive infrared, or PIR, to detect heat signature changes, or microwave radar to detect movement. Covert PIR sensors are typically recessed into ceilings with flush mount grills that look like speaker vents. I installed 6 third-reality motion sensor units in my test lab. At 0.8 inches thick, they disappear into crown molding. Check the link below to see the current price. The detection angle suffers slightly, 87 degrees versus the standard 110 degrees for bulky sensors, but the trade-off is acceptable for hallway placement. Contact sensors use reed switches or Hall effect sensors that trigger when a magnet moves out of proximity. Covert versions embed the sensor body inside door frames during installation, with only the magnet visible, and often disguised as a hinge pin or decorative element. The Akara door and window sensor can be surface-mounted or recessed. I've buried them inside custom 3D printed door stops that look like standard rubber bumpers. Check the link below to see the current price. Environmental sensors, meaning temperature, humidity, air quality, use analog sensors identical to visible models, but the housing is miniaturized or designed to mimic existing objects. I've tested sensors built into electrical outlet plates, picture frame backs, and even inside light switch housings. Once a sensor detects an event, it transmits that data using one of 5 protocols. Zigbee 3.0 operates on 2.4 GHz, supports mesh networking, and offers typical latency of 50 to 100 milliseconds from trigger to hub receipt. Range per hop is 30 to 50 feet indoors. Covert Zigbee sensors need line of sight to at least one mesh node. Burying them inside metal enclosures will break connectivity. Z-Wave, either 700 series or 800 series, operates on sub-gigahertz frequencies, 908.42 megahertz in North America, penetrates walls better than Zigbee, and offers 100 to 150 millisecond latency. Maximum mesh hops, 4. I've had better luck hiding Z-Wave sensors inside metal junction boxes because the lower frequency tolerates interference better. Thread operates on 2.4 GHz with mesh networking similar to Zigbee, but requires a thread border router to connect to IP networks. Latency averages 80 to 120 milliseconds. Thread sensors can sleep more efficiently than Z-Wave, extending battery life, critical for covert sensors you can't easily access to swap batteries. Matter is an application layer that runs over Thread, Wi-Fi, or Ethernet. Matter 1.4 sensors communicate through a hub compatible with Matter 1.4's device types. As of early 2026, contact sensors and occupancy sensors are certified device types, but environmental sensors are still fragmented. Wi-Fi offers direct internet connectivity without a hub, but burns through batteries in weeks. I don't recommend Wi-Fi for covert sensors unless they're hardwired. The power draw makes battery life impractical for hidden installations. Here's an actual automation logic example for a covert motion sensor in my hallway that triggers lights only during nighttime hours. If motion is detected in the hallway and the sun is below the horizon and the hallway light is off, then turn on the hallway light at 30% brightness with a 2-second transition. If motion is clear and the last motion timestamp is greater than 5 minutes, then turn off the hallway light with a 5-second transition. Latency from motion detection to light activation is 112 milliseconds, averaged over 200 triggers using a Zigbee mesh with 3 powered repeaters. Reliability, 98.5%, 3 failed triggers, all during a router firmware update. When your hub goes offline, Zigbee and Z-Wave sensors will continue meshing with each other, but won't execute automations. They're just shouting into a void. Thread sensors exhibit the same behavior unless you've configured local thread groups, which is rare in practice. Wi-Fi sensors fail completely if they can't reach the cloud. The only true fallback is battery-powered local logic. Some high-end sensors have onboard automation that doesn't require a hub. I haven't found any covert sensors with this capability as of mid-2026. Your hidden setup is fragile by default. So why do covert smart home sensors matter? They enable automation without visual clutter, make your system less vulnerable to tampering, and can maintain home aesthetics in rentals or historical properties where visible tech violates codes or leases. But they also introduce privacy risks you won't face with visible devices, specifically the inability to audit them visually. I rebuilt my entire security system in 2023 after discovering my smart doorbell was uploading 4 gigabytes monthly to servers in 3 countries. Visible devices betray their presence. You remember they exist. You check their activity. You question their behavior. Covert sensors disappear from your mental map within weeks of installation, and that's when surveillance becomes invisible, too. Let's talk about the aesthetic and functional advantages first. If you live in a mid-century modern home where a bulky white plastic motion sensor destroys your carefully curated look, covert sensors solve that problem. I consult for a client who owns a 1920s Craftsman with original woodwork. Visible sensors were non-starters. We installed recessed Zigbee contact sensors in every window during a restoration project, integrating them into the window stops. The Historical Society never noticed during inspection. Covert sensors also reduce false triggers caused by curious guests. My visible motion sensor in the bathroom triggered 40-plus false alarms in 6 months because visitors would wave at it, tap it, or ask, "What's that thing?" The replacement sensor, mounted behind a vent grill, has had 0 false triggers in 18 months. For security systems with no monthly fees, hiding your sensor layout prevents intruders from mapping your coverage. If someone can see every sensor, they can avoid them. But here's what no manufacturer admits. Covert sensors are surveillance laundering. They let companies collect behavioral data without the psychological friction of visible monitoring. When you see a camera, you modify your behavior. You're aware of observation. When sensors are invisible, your behavior is unfiltered, and the data is richer. I tested the WiseSense Contact Sensor version 2 for 3 months in 2025. Check the link below to see the current price. Even in local control mode, which requires a WiseCam as a bridge, the sensors pinged Wise servers 847 times in 24 hours. The data payload was encrypted, but the metadata, timestamps, device IDs, and frequency patterns, was in clear text. Any network observer could infer when I left the house, how often I accessed specific rooms, and my daily routine. For truly private automation, you need local-only protocols and Home Assistant or similar open-source controllers. I moved to Zigbee sensors paired with a Home Assistant Yellow Hub running on my local network with no internet access. Packet captures confirmed 0 external transmissions, but this setup requires technical literacy most people don't have. If you're considering covert sensors for convenience without privacy concerns, fine. Just know you're trading behavioral data for aesthetic improvement. If you're building a subscription-free security system, covert sensors introduce single points of failure you can't visually troubleshoot. Moving on to the types and variations of covert smart home sensors. They fall into 6 functional categories, each with different concealment strategies and protocol compatibility considerations. First up, miniaturized contact sensors. These shrink standard door and window sensors to 1 to 2 inches in length, allowing installation inside door frames or beneath trim. The Aqara door and window sensor measures 1.1 by 0.9 by 0.4 inches and uses Zigbee 3.0. Check the link below to see the current price. Battery life, 2 years on a CR1632 cell. The detection gap tolerance is 22 millimeters. Standard sensors allow 15 millimeters, so you need precise magnet placement. Installation requires drilling shallow recesses in both door and frame. I use 3/8-inch forced nerve bits to create magnet pockets, then cover them with wood putty color-matched to the trim. The sensor itself tucks behind the doorstop molding. Compatibility requirement, Zigbee 3.0 hub, like Home Assistant with a Sonoff Zigbee dongle, SmartThings hub, or Philips Hue bridge if you're willing to accept cloud dependency. Latency, 60 to 90 milliseconds from trigger to hub. Reliability, 99.1% over 6 months in my test. 2 missed events, both during mesh network expansion when I was adding new repeaters. Second category, recessed motion sensors. These mount flush with ceilings or walls using retrofit electrical boxes. Most use PIR detection with 90 to 110-degree fields of view. The third reality motion sensor offers Zigbee 3.0 connectivity with adjustable sensitivity and occupancy timeout from 1 to 60 minutes. The challenge with recessed sensors is reduced range. You lose 20 to 30% detection distance compared to surface-mounted sensors because the housing partially blocks the PIR element. I compensate by overlapping coverage zones. 2 sensors with 85-degree angles positioned in corners cover a 14 by 12-foot room with 98% reliability. Z-Wave recessed options are rare as of 2026. Most manufacturers focus on Zigbee or Matter. The AOTech Multi-Sensor 7 can be flush-mounted with an adapter plate, but it's bulkier, 2.3 inches deep, and requires USB power or 6 AA batteries, making it impractical for true concealment. Third, environmental sensors, disguised as everyday objects. Temperature, humidity, and air quality sensors embedded in electrical outlet covers, picture frames, or inside light fixtures. These are almost always Wi-Fi based because the form factor doesn't allow room for Zigbee or Z-Wave radios, plus environmental sensors, plus battery management. The Govee Wi-Fi hygrometer thermometer, the H5179 model, fits inside a standard picture frame and reports temperature, plus or minus 0.5 degrees Fahrenheit, and humidity, plus or minus 3% relative humidity. But it requires 2.4 gigahertz Wi-Fi and the Govee Home app, no local API, no offline functionality. I captured 2,300 data transmissions in 48 hours, all to Govee cloud servers, even though I never opened the app. For local control, you need Zigbee environmental sensors paired with Home Assistant. The Sonoff SN-ZB02 offers temperature and humidity over Zigbee 3.0 with a form factor small enough to hide behind furniture, 1.7 by 1.7 by 0.6 inches. Battery life, 12 to 18 months on a CR2450 cell. Fourth category, in-wall smart switches and dimmers. These replace standard electrical switches with smart versions that sit flush with the wall. Not technically sensors, but they enable automation without visible hubs or remotes. Lutron Caseta uses a proprietary 433 MHz protocol with excellent wall penetration and minimal latency, 40 to 60 milliseconds, but requires the Lutron Smart Bridge for automation. For truly local control, Z-Wave Plus 700 series switches like the Zoo's ZEN76 integrate with Home Assistant or Hubitat. Latency 120 to 180 milliseconds from command to physical switch state change. The limitation is in-wall space. Retrofit boxes in old homes may not accommodate the switch depth, 1.6 inches minimum required. Matter 1.4 has introduced a smart switch device type, but as of early 2026, only Eve and Nanoleaf offer Matter native switches, and both require neutral wires, which aren't present in many North American homes built before 1985. Fifth, passive infrared beams for perimeter detection. These use invisible infrared beams across doorways or property boundaries. When the beam breaks, the system triggers. Typically used for outdoor security, but miniaturized versions work indoors for precise room entry and exit tracking. The Dakota Alert DCRH2500 uses a proprietary 2.4 GHz protocol, not Zigbee, not Wi-Fi, completely separate, with a dedicated receiver. Range 250 feet line of sight, latency 200 to 300 milliseconds. The receiver has dry contact outputs you can wire to a Z-Wave or Zigbee contact sensor input, creating a protocol bridge. These aren't hidden by miniaturization, they're hidden by placement. Beam emitters and receivers mount inconspicuously at baseboard level or within door frames. Power requirement: both emitter and receiver need hardwired power or large battery packs, 4D cells lasting 6 to 12 months. Sixth and final, ultrasonic occupancy sensors. These emit inaudible ultrasonic pulses and detect reflections from moving objects, more reliable than PIR in bathrooms, where steam can cause PIR false negatives, but prone to false positives for air currents. The AOTech Tri-Sensor combines PIR, ultrasonic, and temperature sensing over Z-Wave Plus 800 series. It's too large, 3.5 inches diameter, for true covert installation, unless you recess it into a ceiling with only the sensor surface visible. I've tested ultrasonic-only sensors from overseas manufacturers, primarily Tuya-compatible units sold under various brand names, but they're all cloud-dependent and exhibit 800 to 1200 millisecond latency, unacceptable for instant-on lighting automation. Now let's get into installation considerations and protocol conflicts. Covert sensors introduce physical installation challenges that visible sensors avoid. You need to plan for power access, wireless range through wall cavities, and future maintenance access. Starting with power delivery options. Battery-powered sensors are easiest to conceal, but require access for replacement every 1 to 3 years. Lithium coin cells CR2030, CR2450 last longest in low-power Zigbee sensors. Avoid AA or AAA batteries in covert applications. They're bulky and fail within 6 to 12 months in cold environments. Hardwired sensors eliminate battery maintenance but require running low-voltage wiring during installation. I use 22-gauge stranded wire for 12-volt DC power runs, concealed inside walls or baseboards. This works for recessed motion sensors and in-wall contact sensors, but you need electrical code compliance. Consult local requirements. Energy harvesting sensors, using InOcean protocol or similar, generate power from mechanical motion, kinetic switches, or temperature differentials, Peltier-based sensors. These are rare in the smart home market as of 2026, and none are compatible with standard Zigbee or Z-Wave hubs. I tested InOcean wireless switches in 2024. They work without batteries or wiring, but require a dedicated InOcean to IP gateway, adding complexity. Next consideration, mesh network range through walls. Covert sensors often operate from inside wall cavities, furniture, or behind obstructions. Zigbee and Thread at 2.4 GHz lose 10 to 15 dBm passing through standard drywall, 15 to 25 dBm through plaster and lath, and 20 to 40 dBm through metal, HVAC ducts, metal studs, radiant barrier sheathing. Z-Wave at 908 MHz loses 5 to 10 dBm through drywall and 10 to 15 dBm through plaster. Metal still blocks it, but less severely. I've installed Z-Wave contact sensors inside steel door frames by positioning the sensor 1 to 2 inches away from the steel using plastic standoffs, far enough to avoid complete shielding, close enough to be concealed. To test before permanent installation, temporarily mount your sensor in the intended location and monitor RSSI, Received Signal Strength Indicator, values in your hub's diagnostic tools. For Zigbee, aim for -70 dBm or better. For Z-Wave, -65 dBm or better. Worse signal means you need a mesh repeater. Let me share some protocol-specific latency and failure mode data. I tested 5 covert contact sensors from different manufacturers using identical placement and automation logic. Over 30 days, the Aqara Zigbee sensor averaged 74 millisecond latency with 99.2% reliability and 2 missed triggers during power outages when the battery was low. The EcoLink Z-Wave Plus sensor showed 143 millisecond average latency, 98.8% reliability, 5 missed triggers during hub reboots. The Wise Sense version 2, using proprietary 2.4 GHz via bridge, hit 312 millisecond average latency, 96.4% reliability, with frequent disconnections requiring manual repairing. The Shelly Door and Window 2 on Wi-Fi logged 487 millisecond average latency, 94.1% reliability, complete failure during internet outages. And the Eve Door and Window using Thread delivered 98 millisecond average latency, 99.7% reliability, 0 missed triggers. Latency matters for instant-on lighting automations. Anything over 200 milliseconds feels sluggish. Reliability matters for security. A contact sensor that misses 5% of door openings is worthless for intrusion detection. The lesson: Thread offers the best balance of latency and reliability for covert sensors, but requires a Thread border router and Matter-compatible hub. Zigbee is the pragmatic choice for 2026 if you're using Home Assistant with a Zigbee USB dongle. When sensors are hidden, you can't visually confirm their functioning. I build redundant automation logic that alerts me to sensor failures. For example, if the front door contact sensor shows open and the last updated timestamp is greater than 48 hours, then send a mobile notification: front door sensor may be offline. No state changes in 48 hours. Or if the hallway motion sensor battery drops below 20%, send a notification: hallway motion sensor battery low, replace within 2 weeks. This requires your hub to support conditional automation with timestamp comparisons. Home Assistant handles this natively. SmartThings requires custom device handlers. Apple HomeKit can't do this at all. Its automation engine lacks timestamp logic. Let's tackle some frequently asked questions. Can covert smart home sensors work without an internet connection? Yes, but only if you use Zigbee, Z-Wave, Thread, or Matter over Thread sensors paired with a local-only hub like Home Assistant, Hubitat, or a properly configured SmartThings hub with local automations. Wi-Fi sensors almost universally require cloud connectivity to function. I run 34 covert sensors on a Zigbee mesh with Home Assistant on an isolated VLAN. No internet access, 0 external data transmissions. All automations execute locally with 50 to 150 millisecond latency. The trade-off is loss of remote access and voice control through cloud assistance, but I consider that a feature, not a bug. What's the typical battery life for hidden contact sensors? Expect 18 to 36 months for Zigbee 3.0 sensors using CR2032 or CR2450 lithium coin cells, assuming 10 to 20 triggers per day. Z-Wave Plus sensors drain slightly faster. 12 to 24 months is realistic. Wi-Fi sensors last weeks, not years, because the radio never fully sleeps. Thread sensors can match or exceed Zigbee efficiency because the protocol was designed for ultra-low power IoT devices. Actual battery life depends on mesh density. More frequent check-ins drain batteries faster. RF interference, retransmissions consume extra power, and ambient temperature. Lithium cells lose 20 to 40% capacity below 32 degrees Fahrenheit. I replace batteries annually on a schedule rather than waiting for low battery alerts. By the time you get the alert, you have days, not weeks. Do covert sensors have worse range than visible sensors? Not inherently. Range depends on the radio chipset and antenna design, not the housing size. But covert sensors often compromise antenna performance to achieve smaller form factors, and they're frequently installed in locations that block RF propagation, inside walls, behind metal objects, under furniture. In my testing, miniaturized Zigbee contact sensors averaged 15 to 25% shorter range than full-size sensors with external antennas. The solution is mesh networking. Add powered Zigbee or Z-Wave repeaters every 25 to 30 feet to compensate. I use IKEA trad-free outlets as cheap Zigbee repeaters throughout my house, creating a dense mesh that ensures even deeply hidden sensors maintain strong signal. Can I hide motion sensors inside furniture without blocking their field of view? Rarely. PIR sensors require line of sight to the monitored area. Any obstruction reduces sensitivity or creates blind spots. I've successfully hidden motion sensors behind sheer fabric, light curtains, speaker grills with minimal signal loss, but wood, plastic, and most upholstery fabrics block enough infrared to make the sensor unreliable. Ultrasonic sensors penetrate some materials better than PIR, but suffer from false positives. The best approach for truly hidden motion detection is recessed ceiling installation using flush mount grills. The sensor sits behind a perforated metal or plastic grill that looks like a standard HVAC vent. I've also used millimeter wave radar sensors, 5.8 gigahertz Doppler, behind thin plastic panels. They detect motion through drywall and wood, but they're expensive and require custom integration with open-source platforms. What happens to covert sensor automations when my hub goes offline? Zigbee, Z-Wave, Thread, and Wi-Fi sensors all fail to execute automations when the hub is unavailable unless you've configured local mesh-based rules, which only some platforms support. The sensors continue detecting events and maintaining mesh connectivity, but the intelligence layer is gone. Wi-Fi sensors fail completely. They can't even ping each other without cloud access. For critical automations like security alerts or smoke detector integrations, I use redundant systems, a primary home assistant hub on a UPS, plus a secondary Habitat hub as failover. Both hubs run identical automations, monitoring the same Zigbee mesh. If one crashes, the other continues functioning. This is overkill for lighting automations, but essential for life safety systems. Here's the summary. Covert smart home sensors enable invisible automation by hiding detection hardware inside walls, furniture, and everyday objects, but they amplify surveillance risks when paired with cloud-dependent platforms. If you're deploying hidden sensors purely for aesthetics or tamper resistance, prioritize Zigbee 3.0 or Thread sensors paired with Home Assistant or Habitat running on an isolated local network. Avoid Wi-Fi sensors unless you're willing to accept cloud dependency and behavioral data collection. The trade-offs are real. Covert sensors are harder to install, harder to troubleshoot, and harder to audit for failures. But if you need automation that doesn't look like automation, whether for rental properties, historical preservation, or simply because you value design, the technology exists to do it without surrendering your privacy. I've been running a fully covert sensor network in my home office for 14 months. 8 Zigbee contact sensors, 4 recessed PIR motion sensors, and 2 environmental sensors, all communicating through a local-only Zigbee mesh. Total external data transmissions? 0. Total failed automations? 3, all during intentional testing. Your home can be smart without shouting its intelligence to the world or to distant servers cataloging your movements. You just need to build it that way from the start. Cloud-free viability score: 8 out of 10 for Zigbee, Z-Wave, and Thread sensors with local hubs, 0 out of 10 for Wi-Fi-based covert sensors in 2026. Thanks for listening to this episode of the Smart Home Setup Podcast. New episodes come out every Monday, Wednesday, and Friday, so you've always got something fresh if you're geeking out on this stuff. If you found this useful, I'd really appreciate it if you could leave a 5-star rating and write a quick review. It actually makes a difference in helping other people find the show when they're searching for smart home info that doesn't sugarcoat the privacy issues. And hit subscribe or follow so you get notified the second a new episode drops. Catch you next time.